and we haven't talked about this for a little while, so we're going to kind of review this a little bit as well. When we do what we call the geometric mean, then we're going to end up with a radical in our answer in a lot of cases. And so what we have to be able to do is we have to be able to simplify that radical, and it's something we did a little bit of in Algebra 1, but it's been a little while since we've done that. So I'm going to show you some different ways that you can simplify radicals. Also, we've heard of the word mean before, okay? When we saw or heard mean before, anybody remember where we've seen that? When I talk about the mean. Average, right? And so that is actually what we call the arithmetic mean. We add them up and divide by 2. We find the middle number, okay? And that is not what we're doing today. Today is what we call the geometric mean. So this is a different type of mean than what we've done in the past. You probably remember like mean, median, and mode. Well, that's not what we're going to be doing today. So just, if you do remember that, just trying to make sure you understand that it is different. And the word might sound familiar, but the math is different. When we set these up, as long as I have 2 positive numbers, the way that the proportion is going to look, 24 goes to x as x goes to 48. And we're going to do the same thing that we've been doing for the last week or so. We're going to cross multiply and we're going to solve. And so if I take 24 times 48, what do I get? 1,150. Okay. And if I take the square root, because we talked about this yesterday, if I take the square root to get x by itself, when I take the square root of 1,152, then do I get a nice whole number? No. Okay, we get a decimal. Okay? And that's going to tell me right then and there, if I can take the square root of this and get a nice whole number, that's my answer. That nice whole number is my answer. But a lot of the problems today, we're not going to get a nice whole number when we take the square root of this. Okay? So we don't want to write the decimal. Okay, we're going to write an exact answer. That's the one thing that we've talked about a lot, is writing an exact answer. So as I take the square root of this, okay, 1,152 is a fairly large number, right? And so there's a couple of different ways that we can approach this. But I'm going to go back to like a real, this did. 1,152 is a fairly large number. If I'm going to make a tree for this, it's going to take me a while, right? So I'm going to show you some shortcuts. I'm looking for pairs. And so the first thing I would do here is, I know that I multiplied 24 and 48 together at the very beginning, right? Everybody agree with me there? So I know this is really 24 times 48. And here's what you can pay attention to, okay? What do I know? What's the relationship between 24 and 48? What'd you say, Karthik? 24. Yeah, 24, right? 24 times 2 gives me 48. So I could rewrite this as this, because this gives me this, okay? And the reason why this is helpful is because, look what we got here. We got a pair, right? We have a pair of numbers. So whatever we have a pair of is going to come out. Okay, so what I want you to try to pay attention to today, because when we have big numbers, it's going to make it a little bit more difficult, look for something that maybe goes into one of those two numbers to make it a little bit easier. That way I don't have to break the tree all the way down. Because if I was going to break this up, I would say, okay, 6 times 4, and then I got to keep breaking it down. It's going to take me a while to get there, okay? And so this would be what we call our simplified answer. If you take the square root of 1152, and you take 24 times the square root of 2, I get the same decimal. Okay, those two are exactly the same thing. But this would be the way we want to leave it. Simplified. All right, so here's what I'll tell you on these problems. If it says geometric mean, and there's no picture or anything like that given, okay, you don't necessarily have to rewrite the proportion, okay? Basically what we're saying here is x squared equals the product of those two numbers. Same thing as I did here. X times x is x squared. These are the two numbers that are multiplied together. Okay? And then I'm going to take the square root of both sides. Here's where I'm going to start to break it down a little bit. So the first thing I would do, I could break 12 up into 3 times 4. What's something that goes into 27? 9 times 3. Okay, and you got a couple of options here. You could keep breaking it down. You got pairs of 2s. You got another pair of 3s. Okay, and that's what it would look like. I have a 3, I have 2 2s, 2 3s here, and then another 3 at the end. Okay, so I got a pair of 2s. I got a pair of 3s, and then I got another pair of 3s right here. Okay, so I have a 2 and 2 3s. Do I have anything left inside that's not paired up? No. Okay, so on the outside, I would have 2 times 3 times 3, which would give me 18. So here we don't have a radical left as our answer, right? Here's what. Take 12 times 27. What is 12 times 27? 324. Okay. What happens if I take the square root of 324? You get 18. Okay. That would probably be the easier way to go. Always check that first. Okay. If it's a nice perfect square, if I take the square root of 12 times 27, it would just give me 18. I don't have to do all the breaking it down like I did here. Okay. I could have just jumped right away here and said 18. It's a lot easier to do. Okay. Make sure that if you were to do it that way, either you do 12 times 27 first and then take the square root, or you can do the square root of 12 times 27, but they all have to be underneath the radical. Okay. I will tell you this, some of your calculators will do simplest radical form for you. Some calculators don't. Okay, and all I can say is, if you got a calculator that does radical form, then you're in a better shape and maybe a little bit lucky. Some calculators, you have to actually do the radical form by yourself. So if you have, some of you might say, well, my calculator's doing the radical form for me. That's something that some of the calculators do now. Okay, so the first thing that we should always check is, what's 18 times 54? How much? 18 times 54? Okay, and then take the square root of that. It's a decimal. Okay, so we don't want a decimal answer here. Okay. We want to leave our answer as a radical, so right now that tells us we got to break this down. So one thing I'm going to show you here. You can break it all the way down like we did here, or you can do it like we did up above. Does 18 go into 54? Is 18 a factor of 54? Take 54 divided by 18. Yeah, how many times? 3. So here's what I could do. I'm going to leave the first 18 alone, and then 54 is going to break up into 18 times 3. The reason I'm not going to break it all the way down into prime factorization is because right here, do I have pairs? Yes, it's a lot quicker, right? If you can find pairs right here, you don't need to keep going down. I have a pair of 18s right now. And so the 18s are going to come on the outside. 3 is going to stay on the inside. And that's my answer. Question so far. You guys kind of remember doing radicals before? Or is this like foreign language right now? Okay, thanks for the feedback, guys. Yeah. Need some feedback here, guys. Are we feeling good about this? Or is this like, I've never seen this before?
Kind of both.
Kind of both? A little bit of both? Okay.
Kind of like separating numbers into smaller numbers.
You don't like doing that? Why not? Just because? All right, let's do one more here. And maybe this is what you guys want to do. So would you rather just go all the way down to the prime factorization? Would that make more sense? I mean, you guys tell me. Yes? No? Let's go to the prime factorization on this one, and then you can kind of decide how you want to go about this. So what is 16 times 18? 280 what? 288. Okay. So x squared equals 288. Okay. So we're going to start with 288. I want to find one thing that goes into 288. Anything you want it to be. Well, we already know one thing that goes in there. 16 times 18, right? We could use that if we want to, or we could do like 2 and 144. Okay? It's up to you. Let's say we used 16 times 18 because I already know that went into it, right? And then I'm going to break it down. What's something that goes into 16? 4 and 4, okay? And then 18 would be 2 and 9. 2 is prime, nothing else is. So I keep breaking it down. So I have a 2, another 2 and 2, and then a 3 and a 3. So here are all of our prime factors. So if we wrote this out, I have 1, 2, 3, 4, 5 2s and 2 3s. Okay? I'm going to write that inside here. 1, 2, 3, 4, 5 2s and 2 3s. If I multiply all of this back out together, it would get me here. That's all that we're doing. We're breaking it down into a prime factorization. You don't have to check it. I mean, if you wanted to check it, you could. All of this multiplied together should get me back to there. That's what we've done, okay? We're looking for groups of 2, pairs. I have a pair of 2s, another pair of 2s, and a pair of 3s. Anything that is paired up is coming out. So on the outside, I have 2 2s and a 3. On the inside, I just have a 2 left over. Anything that's on the outside here, we're going to multiply those together. Which is that, Brian?
Since 4 is already a pair, I just want to put it in the
That would work too. Yep. Anytime you see a pair, you could just leave that as a pair. Yep. And that's kind of like what we did up here. I see a pair of 18s, I could just leave it as a pair of 18s. Okay? So anytime we have a pair, we can just move that pair out. Okay? So yeah, great point, great question. You can leave a pair at any point in time that you have a pair. So all this first page is really just kind of remembering how to simplify a radical. We haven't really done the geometry behind it yet, okay? But that's what we're going to see a lot of today, is simplifying radicals and writing our answer in that essential form. Basic one. The square root of 12. Okay, not quite as big. Just to kind of show you the process here, to kind of get you to understand what's going on. If I was going to simplify the square root of 12, then one way that you probably might remember doing this is we're going to break down into like a tree. We're going to find something that goes into 12, anything, okay? And so you could do 4 times 3, you could do 6 times 2, you can find anything that goes into 12, okay? You just got to choose one thing. So maybe we do 4 times 3. And I'm going to keep breaking it down until I have all prime numbers. And so 3 is a prime number. Nothing goes into 3 other than 1 and 3. That's what makes it prime. 4 is not prime. So this is 2 times 2. 2 is a prime number. 2 is the only even prime number. Most even numbers, 2 goes into them, but 2 is prime, because the only thing that goes into 2 is 1 in itself. So if we were to break this down, I could do 2 times 2 times 3. If I multiply these 3 things together, it gets me back to 12. And then what we're looking for is we're looking for pairs. What do I have pairs of? Well, I've got pairs of 2s. Whatever I have a pair of is going to come out, and that goes out here. Whatever did not pair up stays inside. So 2 radical 3 is what we call the simplest radical form of that answer. Okay. If you were to do the square root of 12 in your calculator, it's going to give you a decimal. Okay. If I type in 2 times radical 3 in my calculator, it would give me the same exact decimal. Those two are equivalent. It's kind of like 1/2 and 0.5 are the same thing, right? This is just the simplified version. If I have the way I think about it is if I have 6 over 12, that's a fraction, right? But we don't ever leave it as 6 over 12. We always reduce it to be 1/2. The 1/2 is the simplified version. We don't leave it as 6 over 12. Same thing here. We don't want to leave our answer as radical 12. We want to simplify it to 2 radical 3. Now, I'm going to also show you this. Your perfect squares are good numbers to be able to recognize. Okay, and there's your first 10 perfect squares. I should include 1 because 1's a perfect square as well. Those are your first 10. When I see those numbers, I should know those are perfect squares. When I see 49, I know it's 7 times 7. When I see 16, I know it's 4 times 4. Taking a number times itself to get me to one of those numbers. There's other ones that you might know too. You might know 11 squared is 121. 12 squared is 144. And I could keep going, right? But these are the 10 that you should know. When I see them, I know they're perfect squares, okay? And you might have seen those before, but just kind of a quick reminder. From 1 to 100, those are your first 10 perfect squares. Another way that I like to do this, and I'm going to do the same problem. I'm going to find a perfect square that goes into 12. And I'll show you why I like this method a little bit better. 4 times 3. And if I take, let's say I covered this up, if I take the square root of 4, what do I get? I get 2, right? The square root of 4 is 2. And so that's another way to get there. Okay. And either way is fine, okay? But the bigger the number, it's going to be hard to do the tree. And so if we go back to the one that we okay, I'm going to try to make this as simple as possible. For this first one up here, we saw this picture yesterday, okay? And what I'm going to tell you is, for today, you don't necessarily have to redraw this picture. I'm going to show you an easier way to kind of set some of these up. And that way, we can save the time of having to redraw. Really, the only time you're gonna have to redraw them from here on out is if I wanted to identify like all three triangles that were similar. And that's what we used it for yesterday. Triangle ABC is similar to DEF, which is similar to LMN, or whatever the three triangles are. Here, we're just really solving today. And so we're gonna use the geometric mean to solve these answers. And so the first one here is gonna depend on where the X is at. But the X, a lot of times, is gonna be this altitude right here. And we had one like this yesterday where that was like the height of the house or something like that. Okay, and so we could have used this yesterday, but we hadn't learned this rule yet. And so this is the formula right here that we're using. Okay, so I'm gonna put a star by that. And when I do this, the altitude breaks the hypotenuse up. Okay, so we're going to take the two parts of the hypotenuse, dB goes to the hypotenuse as the hypotenuse, sorry, at altitude I should say, not the hypotenuse, goes to the altitude as the altitude goes to dA. Okay. And so I'm going to show you how we can use this to help us out, okay? And we're going to do some examples with that here in just a second. Down here, the length of the altitude is the geometric mean of the lengths of the segments of the hypotenuse. So this is my altitude, okay, and this is going to be AD to BD, like we just talked about. They're just writing it out rather than doing a proportion. So I'm going to multiply these two pieces together, and that's going to be the same as the altitude squared, okay? Now this one down here is going to be a little bit different. This one down here, I'm going to say AB is to BC as BC is to DB. I'll tell you what this is talking about, okay? AB is the hypotenuse of the whole thing. And if you wanted to write that, you could write hypotenuse above it. Okay, BC, we're using this piece twice right here. So I'm going to go AB to this part of the leg, okay? So BC is one of my two legs, and we're going to use that twice, whichever leg you want to use. And then this BC is the hypotenuse of the small triangle, so it's going to match up with DB on that small triangle, okay? And we can do two different variations of that. If I wanted to find the other leg, okay? So I'm still going to use AB. AB goes to the other leg. So here we used BC. Now I'm going to use AC. And now if I look at the medium-sized triangle, this hypotenuse matches with this part of the hypotenuse. So we're splitting that hypotenuse up into two pieces. Okay. Oh, I wrote it down wrong. That's my fault. AC was the actual leg. Oh, sorry. AB goes to AC. Nope, I wrote it right as AD. Okay, so AC is the part that we use twice. The leg that we're doing here, and then we're going to compare it to that piece there. Okay, so this one up here, let's do this. I'm using the small triangle. This one down here, I'm using the medium triangle that we did yesterday. Okay, it'll make a little bit more sense when we put some numbers to it. because you're not gonna have 4 unknowns. You're gonna have 3 things that we know. We're gonna have 1 piece that we're trying to find. And I'll try to explain it better with some numbers that we have. Because this, I think, can be a little bit confusing. Okay, and I'll try to show you the pattern that we're gonna use here in just a second. Okay. So let's go to example 4, and I'll kind of show you the pattern that we're going to use here. I'm going to add another problem here because you're going to see one like this, and there's not one like this on our notes. So if you want to add this to like the top. Okay, this is the hypotenuse of the big triangle. Okay, it's been split by the altitude. So if I wanted to find x here, I'm going to say 6 is to x as x is to 3. We're going to use that altitude twice. 6 goes to x as x goes to 3. The 2 x's are going to be diagonal from one another in the proportion. So this is leg to leg, leg to leg, but x is the piece that's going to match up here. Okay? So if you are trying to find the altitude, that altitude is going to break that hypotenuse up, and we set up a proportion. 6 is to x as x is to 3. If I cross multiply here, I get x squared equals 18. I got to break it down. Is 18 a perfect square? No. So we got to break it down. What is something that goes into 18? 6 and 3. Okay? So if you would rather just do like the tree diagram up here, we could do 3 and 6. 3 is prime. 6 breaks up into 3 and 2. And I'm going to write out the 3 things that it breaks up into. 3 times 3 times 2. What do I have pairs of? I've got a pair of 3s. That's going to come out. So that would become 3 radical 2. That would be our answer. Okay, I wanted to put that one on here because it's a little bit different than the next 3. If you look at the next 3, we don't have anything labeled on the altitude. So this question here is when the altitude is what we're trying to find. Okay, so just make a note of that. On this one here, x is a leg of the original triangle. Okay? So when x, or we know a side of the leg, here's how we're going to set this one up. And then I'm going to show you a shortcut. X is to nine, because 9 is the length of this whole thing. As 6 is to x. Okay, so this is the leg of the entire triangle, and this piece right here is my hypotenuse, right? So leg to hypotenuse. And then on this medium triangle here, this is a leg, this is hypotenuse. So we went leg to hypotenuse. So leg to hypotenuse, leg to hypotenuse. When I cross multiply here, I'm going to get x squared equals 15. and now I gotta break it down. Okay, so here's the trick, okay? I told you I would show you a trick, and this is what we're gonna use from here on out. We're gonna have x squared here, okay? And we're gonna multiply the piece that's adjacent to x, 6 is adjacent to x, and we're gonna take it times the whole hypotenuse. So we're gonna take 6 times the whole thing. So that would just be 6 times 9, which is essentially what we did in the proportion right here. Okay? But we don't need to make a proportion every single time for this. Okay, is 54 a perfect square? Nope. Okay, so we're going to break it down. We're going to take the square root of it. Something that goes into 54. 6 and 9. Okay? Neither one is perfect. So we keep breaking it down. Or prime, I should say. So this would be 2 times 3 times 3 times 3. We got a pair of 3's. The pair of 3's are going to come out. Left inside are an extra 2 and an extra 3. Because there's nothing paired up here, we're going to multiply these two numbers back together, and that would give us 6. So this would become 3 radical 6. Hey, a couple more problems. Yeah. You want me to come over there, or just if you want to come over in like 5 minutes? Okay. Okay, I'm going to show you an easy way to do this. Basically this is the same problem, okay? But I don't need to set up a proportion. I'm going to show you kind of a quick and easy way to do this. So first of all, this is a leg, right? A leg of the original triangle. So when I do that, okay, that is going to be the piece that we're going to square. We're going to square the leg. So this is going to be y squared. We're going to multiply the entire hypotenuse times the adjacent leg. So what would be the length of the entire hypotenuse of the big triangle? 7. Okay, the leg adjacent to y is 2. 2 is on the same triangle as y. So we're not going to use the 5, okay? Because I'm now using the small triangle. So y matches with 2. So we're going to take 7 times 2. So y squared equals 14. If I were to break 14 down, what goes into 14? 7 and 2. Okay, do 7 and 2 break down anymore? No. Okay, so this is nice when this happens. I can't break 14 down, so guess what? That's my answer. If there's nothing that pairs up when I break it down, then I just leave it as the radical. Because it's just 2 times 7, no pairs. All right, so let's use this new rule right here. Leg squared equals hypotenuse times the adjacent leg. Leg squared equals hypotenuse times adjacent leg. Okay, the leg that we're trying to find here is x, right? So x squared. What is the length of the hypotenuse of the big triangle? Not everybody at once. 13, right? 4 plus 9. 4 plus 9. Length of the whole hypotenuse, right? 4 plus 9. This whole thing here is 13. What is the leg adjacent to x? Is x next to 4 or is it next to 9? Well, it's x next to 4, right? If this was the leg where x was at, then it would be adjacent to 9. That's all you got to decide here, okay? X squared, the whole hypotenuse, x is adjacent to 4. So 4 is what goes in right here. 13 times 4 is 52. And then we take the square root. 52 is not a perfect square. So we need something that goes into 52. If it's even, what goes into every even number? 2, okay? So I could break it down, first of all, just take 52 divided by 2. That's all you got to do. 26 is even, so I divide it by 2 again. Can I break 13 down anymore? No, 13 is a prime number, right? So this would be 2 times 2 times 13. We got a pair of 2's. Radical 13. Okay, so essentially there's two formulas here today, guys. Okay, there's this formula right here, and then there's this one up here, which the x is what we're squaring. So if I wanted to do this one here, I could do it like this. X squared equals each part of the hypotenuse times each other, okay? So 6 and 3 are the whole hypotenuse, but they're the two parts. So here I would do x squared equals 6 times 3. And those would be the two things that I multiply. Okay, so if x is my altitude, I'm going to multiply these two together. That's it. And then do your radical, okay? If x is one of my legs, then I got to find the adjacent leg to the hypotenuse, okay? It's a little bit tricky, okay? I know it's a little bit different than some that we've doing, but I still think just if you know the rule, know the pattern, and try to use that pattern today when you do your big ideas, that'll make it a little bit easier, okay? Tomorrow we'll talk some more about this. Tomorrow is review day, and if